Welcome to Olympiad Math for Year 4. This is Lesson 22, we'll learn Multiplication Principle and Addition Principle, Part 2. In this lesson, we will continue exploring the multiplication principle and the addition principle, and apply them to real-world problem solving. Common methods for solving problems using these two principles include enumeration, classification, pairing, and tabular representation. These methods help understand and apply the multiplication and addition principles, and the choice depends on the problem's structure and requirements. Example 1. There are two types of chocolate candy in the store, milk-flavored and hazelnut-flavored, and three types of fruit candy, apple-flavored, pear-flavored, and orange-flavored. Ming wants to buy some candy to give to his friends. Question 1. If Ming wants to buy only one type of candy, how many choices does he have? Question 2. If Ming wants to buy one type of fruit candy and one type of chocolate candy, how many choices does he have? For question 1, since Ming is only buying one type of candy, this task can be completed in a single step, and there are two categories of options. The first category is choosing one from the two chocolate candies, which gives two options. The second category is choosing one from the three fruit candies, which gives three options. By the addition principle, Ming has a total of 2 plus 3 equals 5 choices. For question 2, this task needs to be completed in two steps. The first step is choosing a fruit candy, which has three options, and the second step is choosing a chocolate candy, which has two options. By the multiplication principle, the total number of choices is 3 times 2 equals 6. In question 1, the task is completed in one step, and there are two categories of options, so the addition principle is used. In question 2, the task is completed in two steps, so the multiplication principle is used. Example 2. How many numbers can be formed using the digits 0, 1, 3, and 9? The numbers that meet the conditions can be divided into four categories: 1-digit, 2-digit, 3-digit, and 4-digit numbers. The total number of such numbers is the sum of the counts in each category. 1-digit numbers have 4 options, 2-digit numbers have 3 times 4 equals 12 options, 3-digit numbers have 3 times 4 times 4 equals 48 options, 4-digit numbers have 3 times 4 times 4 times 4 equals 192 options. Therefore, by the addition principle, we get 4 plus 12 plus 48 plus 192 equals 256 numbers. The cases for 2-digit, 3-digit, and 4-digit numbers each apply the multiplication principle. For example, to form a 3-digit number, the task is completed in 3 steps. Step 1. Choose the hundreds digit from 1, 3, or 9. 0 cannot be the leading digit, which gives 3 options. Step 2 and Step 3. Choose the tens and units digits from 0, 1, 3, 9, which each give 4 options. By the multiplication principle, the total number of 3-digit numbers is 3 times 4 times 4 equals 48. Example 3. 3 circles A, B, and C lie on the same straight line, as shown in the diagram below. A frog jumps back and forth among the 3 circles. It can jump between A and B, between B and C, or even directly between A and C. It starts at circle A and returns to A after 4 jumps. How many different jumping paths are there? Since the frog starts from any circle, it can land on either of the other two. We can draw a tree diagram to list out all possible jumping paths. From the diagram above, we can see that there are 6 different jumping paths. This problem uses a diagramming method to visually represent a counting problem, listing all valid jumping sequences one by one for clarity. Drawing tree diagrams and other forms of visual aids are common techniques in solving such problems. Example 4. There are 4 small birds and 4 different cages. Each bird has a corresponding cage, and all cages are distinct. Each cage can hold only one bird. If none of the birds fly into their own cage, how many different arrangements are possible? Let the 4 cages be labeled as uppercase A, B, C, and D, and the 4 birds be labeled as lowercase a, B, C, and D. The requirement in the problem is that bird A must not enter cage A, bird B must not enter cage B, bird C must not enter cage C, and bird D must not enter cage D. According to a specific set of rules, we use enumeration to list all possible arrangements. We begin with bird A. Since bird A must not enter cage A, it has 3 possible choices: it can enter cage B, cage C, or cage D. We now examine each case using enumeration. If bird A enters cage B, then bird B can choose from cages A, C, or D. If bird B enters cage A, then birds C and D are left with cages C and D. In this case, bird C must go to cage D and bird D must go to cage C. Here is one valid arrangement. If bird B enters cage C, then birds C and D are left with cages A and D. In this case, bird D must go to cage A and bird C must go to cage D, that is another valid arrangement. If bird B enters cage D, then birds C and D are left with cages A and C. In this case, bird C must go to cage A and bird D must go to cage C, that is another valid arrangement. Therefore, there are 3 valid arrangements when bird A enters cage B. Similarly, when bird A enters cage C or cage D, there are also 3 valid arrangements in each case. Thus, there are overall the 9 arrangements shown in tabular form. When solving this type of problem, it's helpful to label abstract objects with letters or numbers, for instance, naming the birds and cages as lowercase a, b, c, d, and uppercase a, b, c, d. This not only makes the explanation clearer, but also helps convert an abstract concept into a concrete and manageable one, which is a valuable problem-solving habit. Example 5, as shown in the diagram on the right, how many squares are there in a 4x4 grid? We can calculate by categorizing the squares based on their side lengths. 4 squares of side length 1. Once one pair of adjacent sides is determined, the square is fixed. There are 4 horizontal positions and 4 vertical positions to place a 1x1 square. We have 4 times 4 equals 16 squares. 4 squares of side length 2. These can be placed in 3 horizontal positions and 3 vertical positions. We have 3 times 3 equals 9 squares. 4 squares of side length 3. We have 2 times 2 equals 4 squares. 4 squares of side length 4. We have 1 square. Total number of squares is 16 plus 9 plus 4 plus 1 equals 30 squares. The answer is there are 30 squares in total. This problem is solved by applying both the addition principle and the multiplication principle. The total number of squares in a 4x4 grid can be divided into 4 categories based on the side length. Within each category, a square is determined by selecting 2 adjacent sides, that is horizontal and vertical. Each step of this selection uses the multiplication principle, and the total is found using the addition principle. Here are the practice problems for today. Thank you for watching and hope you enjoy your math today.